To control all these systems, we've selected two computers for different reasons. One, we selected the Raspberry Pi mainly for its Linux operating system, which enables us to run multiple processes and more complex operations, such as the data and imaging processing and the aggregation of data, as well as user controls for the system itself. The Arduino we selected, it's useful for embedded systems and more dedicated processes, as well as the large number of analog to digital converters usually on the boards, and the high number of GPIO pins for general purpose. This is an example of the aggregate of the entire system that we're kind of developing here. You can see that there's a dedicated MCU, or in our case an Arduino, for the water and nutrient controls, and then as well as the environment controls, and the claw has its own dedicated controls as well. And you can see the Pi in the middle here kind of as the master of the entire system itself. Here's an example of something that might be on the Arduino. The Arduino itself running a dedicated process that is looking to hold set points for each of the systems that we're trying to control. So take the environment MCU. You can see that it will take the set point changes from the Raspberry Pi, and then as well as send data to the Raspberry Pi. And then inside there, in the main loop here is the PID loops. And if you're familiar with PIDs, then that's a traditional implementation of one, which is going to be a closed feedback loop to control the environment itself.